The key to implementing a type inference engine instead of just a type checker is to replace type equality comparisons, checking whether two types are the same, with type unification. And in particular, the interesting case is when we unify a type variable with some other type, tau2. If t, our type variable, is already set to some other type, tau1, then we can just recur. We can unify tau1 and tau2. Tau1 might, for example, be num or bool, in which case we check whether num or bool can be unified with tau2. Or tau1 might be some other type variable, in which case we recur and unify with that other type variable. If this case doesn't hold, then we go on to the next check, which is to check whether tau2 is already equivalent to t. It may be, for example, that tau2 is exactly t already, in which case there's no new information, but it's fine to say that t equals t. But another possibility is that tau2 is some type variable t3, and t3 has been unified with t previously, so that they're known to be equivalent. That's the same thing. And this can keep going. We can have tau2 equals t3, and t3 equals t4, and so on, and at a chain of type variables end up at t. So what we need in general is a resolve function, which will take any type and follow type variables as needed to resolve the type. So the question here is really, is the resolved tau2 already equal to t? And if so, then we haven't learned anything, but we succeeded, because t is equal to t. Otherwise, we move on to the third case, and we check whether tau2 contains t. So it's not exactly t, but it has t in there somewhere, under an arrow, for example. In that case, the occurs check has failed, and so there's no type check. And so we're going to have an occurs function that takes a type variable and a type to check to see whether this type variable, exists anywhere within that type. Although actually we need to resolve that type first and check whether t is in the most specific thing we already know about that, in case tau2 is itself a type variable. If that third case doesn't hold, then that means there's nothing already that has any constraint between tau2 and t, so we just say that from now on t must be tau2, and succeed for now. This only covers the case where we're unifying a type variable with some other type. In general, if you unify some type tau1 to some other type tau2, then when tau2 is the type variable, then you can just swap them and unify that type variable t with tau1. So all of these other cases will kick back in that case. Otherwise, tau2 is not a type variable, and tau1 is not a type variable. Otherwise, we would have handled things with the first set of bullets up there. So that must be that tau1 and tau2 are either num or bool or arrows. And if they're both num or bool, then that's fine. A num can be unified with num, or bool can be unified with bool. If they're both arrow types, that means that tau1 is t3 arrow tau4, and tau2 is tau5 arrow tau6. Right? In that case, then we just need to unify tau5 with tau3 and tau4 with tau6. For example, if it's num arrow num, then the num here and the num here will unify. Or if it's num arrow bool, then the bool for tau6 will unify with the bool for tau4. On the other hand, if it's num arrow num and num arrow bool, then the bool for tau6 will not unify with the num for tau4. So if none of these cases hold, then it must be that t1 and t2, or tau1 and tau2, are not the same kind of thing. They're not both num or bool, they're not both arrows, and neither one is a type variable. And in that case, we just have to fail. When we fail, we need to report a type error, and we used to report type errors with a function that says this expression is not a particular type written down as a string. So you might pass in an expression and say it's not a num or a bool or a function. We don't have this kind of type error anymore. Now our type errors will all be of the form, this expression is a place where we found two types that were incompatible. A number was not compatible with a bool, say, or a number was not compatible with an arrow type. That kind of error is exactly the kind of reporting you see in Dr. Reckitt. where we have a PLA typed program and I try to add 1 and a number, it doesn't really say that false is expected to be a number. It says I needed a number and I needed a Boolean and I couldn't unify them, and it was somewhere in the vicinity of these expressions. So we're going to report errors in a similar way here, because there's not really much more you can do without lots of special cases when you use type inference.